Hey guys, it's Friday. I wanted to give you a little bit of time to complete that assignment on finding the most appropriate measure of center and variation. So I know there was a lot of questions and some confusion on that, so I wanted to go over it and let you check back on your work and take a look at this video to see the proper way to do this. So the first question to choose what would be the appropriate measure of center and variation, the number one question is that data symmetric? So the data from the problem 677,889, that data is actually perfectly symmetric. There's no outliers. It is symmetric. It's clustered together. Now, if I had, say, a 46, the data would be not symmetric because there's an outlier. So, is the data symmetric? Yes, it is. So, I only do one or the other. I had questions. What about how do I handle it for no? It's not symmetric. I don't go there. If the data is symmetric, I go to the yes side of things, and that means I'm finding the mean and the MAD. Okay, to find the mean, add them all up. Let's see, I have 13, 28, 36, and 9, 45. Okay, and there's 1, 2, 3, 4, 5, 6 pieces of data. So to find the average, I'm going to divide by 6. And 6 goes into 45 7 times for 42, which leaves me 3. And I can really see that I have 3 left over out of 6. So I already know that's going to be 7.5. My average, or my mean, is 7.5. Okay, so I answered a question, and there's 4 answers here. The data is symmetric, so the most appropriate measures of center is the mean. The most appropriate measure of variation is the mean absolute deviation, and now I need to make the calculations. I've made the calculation for my mean. As for the MAD, or the mean absolute deviation, remember, that's really just finding the average of the average. So I'm comparing the absolute difference from 6 to 7.5 is a difference of 1.5. From 7 to 7.5 is a half. It's not negative, it's an absolute difference. So 7 to 7.5, again, a difference of 1/2. 7.5 to 8, difference of a half. Again, 8. I'm comparing to all pieces of data. 7.5 compared to 8 is again a half. And 7.5 compared to 9 is again 1.5. So 1, 2, 3, 4, 5, 6 differences. 1, 2, 3, 4, 5, 6 pieces of data. Okay, now I need to find the average of this new set of differences. 4 halves makes 2, and this would make 3.5, 4.5, 5. Let me check my work. 1 hole, 2 holes, plus 1 more is 3.5, 4.5, and another half makes 5. So I have a sum of 5 divided by 1, 2, 3, I said 6. So I have 5, a sum of 5 divided by 6. This is not going to work, so I need to make it 5.0 and raise my decimal. And 6 will go into 50 8 times for 48, difference of 2, okay? And I can really see I have 2 left over out of 6. I know that's 1/3. I could do this in my head for 0.33333, but with decimals, I'm going to show my work. 6 goes into 20, 3 times for 18, 2 left over, again 0, drop. It's going to be continued 3333. My answer, my mean absolute deviation, is, and I'm going to use bar notation, 83 hundredths. Okay. So, mean absolute deviation is very small. And I know that because the data is very close together. So my mean absolute deviation is less than 1. Meaning, on average, my data is less than 1 from the average. Okay, so the data is, yes, the data is symmetric. Most appropriate is the mean and the MAD. Calculate, the mean is 7.5. And my MAD, my mean absolute deviation, is 83 hundredths. Continued. I know that was a little longer, guys. Longer than I intended. I hope you understand this. Give me some questions. Post below if you have any. All right, guys. Have a great weekend.